Good morning, students. I am K. N. Narsimurthy. Presently, I am working as an assistant professor in Government First Grade Women's College, Tumkur. So, subject which I am teaching is physics, and this is the 60th video. The last video for the second semester students of Tumkur University. So, I have covered all the things, all the units, all the 4 units for the second semester students. This is the last session, the last video which I am discussing with you, and this video is all about the numericals, all about the problems regarding the electrical network. Alright, let's get started with the first problem. In the circuit given below, find the current through 5 ohm resistor using superposition theorem. Okay, so network is given below. So what I need to calculate here is I need to calculate the current which is flowing through the 5 ohm resistance, that too with the help of superposition theorem. Don't do it with any other theorem. It is very clearly mentioned you that you should apply superposition theorem only. Okay, alright. So what is actually the superposition theorem says? The current or voltage in any part of the network is equal to the current or voltage produced by independent source. Okay, first let me take the 10 volt battery and I short circuit this 8 volt battery. I'll remove the 8 volt battery and short circuit it, and I look for the current through 5 ohm resistor, and I will call it as I1. In the second step, I will retain the 8 volts battery and I remove this 10 volts battery and I short circuit it, and I look for the current through 5 ohm resistor. It will be I2. Then I'll take algebraic sum. I1 plus I2 will give us the current which is flowing through 5 ohm resistor with both the batteries together. Okay, that is what actually the superposition theorem says. Okay, alright, I will go according to the superposition theorem. First, I will consider only the 10 volt battery. I have removed the 8 volts battery and I have short circuited the terminal. Now I am looking for the current which is flowing through 5 ohm resistor, and I am calling it as I1. Now my intention is to find I1 here with the only 10 volts battery. Now how do I find the branch current, the current which is flowing through the 5 ohm branch? To find the branch current, I need to calculate the main current which is drawn from the battery. So that is I am calling it as I. You can call it as small letter I, no problem. So current is the main current is the current which is drawn from the battery, drawn from the 10 volts battery. For that, I'll apply simple Ohm's law to find the main current, which is total voltage by total resistance. Yeah, the total voltage is the EMF of the battery, which is 10 volts, and the total resistance, now it is a complex thing. Resistance means it is not a single resistor here, it is the 3 resistors which are connected in a complex manner. You need to take the effective resistance. For the flow of main current, now which are in parallel and which is in series. For the main current, it goes to the 4 ohm, and after flowing through the 4 ohm, at this node it gets divided. A part of it will go to 8 ohm and a part of it will go to the 5 ohm. So current will divides. Where exactly it divides? Exactly at that node. It divides into 2 branches. One is 5 ohm branch, another one is 8 ohm branch. Means these two are in parallel. 5 ohm, 8 ohm are in parallel, and 4 ohm is in series. Alright, I'll apply this. So resistance is 4 ohm in series and 5 and 8 are in parallel. So it is simply 4 plus 5 into 8 divided by 5 plus 8. So that is equal to 4 plus 40 by 13. It is 92 by 13 ohm. Acha, I calculated the resistance. Now my intention is to calculate the main current. So main current is, the Ohm's law tells you that the total voltage by total resistance. Total voltage is 10 volt battery voltage. Total resistance which I have calculated, it is 92 by 13. I have applied it. I got the main current 10 by 92 into 13. Now I need to apply the branch current formula to get the value of branch current, which is the current flowing through the 5 ohm branch. So for that I have been telling you the branch current formula. It is the main current into resistance in the another branch divided by sum of the two resistances. You need to know what are the two branches here. The one is a 5 ohm, another one is 8 ohm. I am looking for the current through 5 ohm. What is the other branch? It is 8 ohm. So main current, which is 10 by 92 into 13 into resistance in the another branch is 8 divided by sum of the resistances is 8 plus 5. So this gives us the branch current, means the current which is flowing through 5 ohm resistor. Alright, if I calculate this, it comes out to be 20 by 23, which is 0.8694 ampere. This is the branch current. This is the current which is flowing through 5 ohm resistor with only one battery, only one source, that is the 10 volts battery. So right, one individual contribution I have calculated. Let us go for the second step and let us find the current which is flowing through the same 5 ohm resistor with other battery 8 volts. Now the 10 volts battery is removed. See, look at the 10 volt is mentioned, but there is no battery over there. It is short circuited. Okay. Now let me find I2. I2 is the current flowing through the 5 ohm resistor. For current through 5 ohm resistor, which is the branch current, you need to calculate main current. Exactly how I did in the first step. So main current is the simple Ohm's law. It is voltage by resistance. Voltage is 8 volts, that is known. Resistance, there are three resistors. One 8 ohm is in series and 4 and 5 ohms are in parallel. Because it is for the flow of current, first it flows through 8 ohm, then it divides at 4 and 5 ohm. So when it divides, these 4 and 5 ohms are in parallel. So R is equal to 8 plus 4 into 5 divided by 4 plus 5. So R is 92 by 9 ohm. Now the main current, I told you that it's a total voltage by total resistance. Total voltage is 8 volts, resistance is 92 by 9. I got the main current. So let us find the branch current by applying the branch current formula. It is the main current into resistance in the another branch by sum of the two resistances. So main current is 8 into 9 by 92 into resistance in another branch. You go and look for the two branches. One is 5 ohm, another one is 4 ohm. So current which I am looking here is the current through 5 ohm. The other branch will be 4 ohm. So it is 4 divided by 4 plus 5. If I calculate this, I will get this I2 as 8 by 23 amperes. So I have find the current through the same 5 ohm resistor with the battery of 8 volts and short circuited this 10 volts terminal. So I got I1, the contribution from 10 volts battery, and I got I2, the individual contribution from 8 volts battery. If I do the algebraic sum according to the superposition theorem, I will get the total current through 5 ohm resistance with both the batteries together. So I'll simply do I1 plus I2 because algebraic sum means both current I1 and I2 are going in a same direction. So I can simply add these two to get the total current. But one condition is, if I1 and I2 are in opposite direction, obviously you have to subtract these two to get the total current. That is what the meaning of algebraic sum. Okay. Luckily in this case, both I1 and I2 are in the same direction. Therefore, the total current will be just sum of these two. So it's 20 by 23 plus 8 by 23. It is 1.216 ampere is the total current which is flowing through the 5 ohm resistance with both the batteries, and I have done using the superposition theorem. Right. The first problem is done. Let us move on to the second problem. Alright, in this network given below, Find the current flowing through the load resistor RL using Thevenin's theorem if RL is 4 ohm. Okay, the network is given, all the resistor values are given, 3 ohm, 6 ohm, 6 ohm, and the battery is also given. The voltage is 36 volts. Only thing is, using Thevenin's theorem, I need to calculate the current which is flowing through the load resistance RL. Okay, so you have to use Thevenin's theorem only. Thevenin's theorem means you can convert this complex network into a simple network. Let us first convert this complex network into simple network, and after that let us find the current through RL. Now to convert this to a simple network, you first need to find the value of VTH and RTH. So value of VTH is ER3 by R1 plus R3. Students, you should know which is R1, which is R2 and which is R3. See, R1 is 3 ohm. You go back and look at the Thevenin's theorem proof. So R1 is the first resistor, 3 ohm. R2 is the second resistor in the same line, in the same straight line. R2 is the second resistance. The middle one, the middle resistor is R3. Now R2, R3 are same. Okay. The VTH is ER3 by R1 plus R3. So VTH is equal to E is known 36 volts. R3 is the middle one, which is 6 ohm, divided by R1 plus R3, it is 3 plus 6. You will get VTH as 24 volt. This is the VTH formula given by the Thevenin's theorem. Alright, so after finding VTH, one more thing is to find the RTH. RTH is R2 plus R1 R3 by R1 plus R3. So substitute it. RTH is equal to 6 plus 3 into 6 by 3 plus 6, because that 3 and 6 are in parallel and this 6 is in series. So substitute it and you will get 8 ohms as RTH. Acha, I have done this VTH, which is 24 ohm, and I have done this RTH, which is 8 ohm. Now what I'll do is I will convert that complex network into this simple network with only one battery, which is called VTH, and only one resistance, which is called RTH. So VTH is 24 volts, which I just calculated, and RTH is 8 ohm, that is also calculated. Now I need to find out the current which is flowing through the load resistor RL, which is a 4 ohm. That's a given data. Now current through RL is a simple Ohm's law. You apply simple Ohm's law, which is voltage by resistance. Voltage is 24 volts. Resistance is the two resistors which are in series, 8 ohm and 4 ohm. These two resistors are in series. So it is 8 plus 4. IL is equal to 24 divided by 8 plus 4. You will get 2 ampere. The current through load resistance is 2 ampere. How I did this? I converted that complex network into a simple network, and I know the value of VTH and RTH. In this simple network, now I am trying to find the current flowing through the load resistance by simple Ohm's law. Okay, so I got the current through load resistance as 2 amperes. Acha, this second problem is also done. Let us move on to the third problem. Yeah, let's start the third problem. What should the load resistance be if the power consumed by it may be maximum? Also calculate the power consumed by the load. Okay, right. Now I need to calculate the load resistance if power consumed by it is maximum. Okay, now for that the suitable theorem which I am going to use is the maximum power transfer theorem. So this is a complex network. I cannot directly apply the maximum power transfer theorem for this complex network. First what I'll do is I will convert this complex network into a simple network. How do I do that? So this can be done by using the Thevenin's theorem. So apply the Thevenin's theorem and convert this complex network into a simple network. Then use the maximum power transfer theorem to get the value of load resistance. and then calculate the power, which maximum power. Alright, I'll go one by one. First, I'll convert this into a Thevenin simple network. For that, I need to calculate VTH and RTH. I know the formula for VTH and RTH. VTH is ER3 by R1 plus R3. R3, I told you, the middle resistance. R1 is the first resistance. So VTH is equal to 6 into 20. Oh, acha, it is, 6, EMF is 6, okay. Resistance R3 is 20 divided by R1 plus R3, it is 5 plus 20. So VTH, the Thevenin's voltage, comes out to be 4.8 volts. So I have calculated the Thevenin's equivalent voltage for this complex network. So second thing, I am going to calculate the Thevenin's resistance, and I build a Thevenin's equivalent network. Alright, the Thevenin's resistance RTH is equal to, there is something mistake in the formula, you please correct it. It is not simply R2, I will tell you what it is. So it is IR3. I am going to find the effective resistance across this 20 ohm. Now 5 and 20 are in parallel and 10 is in series. Okay, it is R2 which is in series and R1, R3 are in parallel. So R2 in series, alright, R2 plus R1, R3 divided by R1 plus R3. You please correct it, it has to be modified. So R1, R3 are in parallel, R2 is in series. So formula will be R2 plus R1, R3 by R1 plus R3. Please correct it. Substitution I have done right. So RTH is equal to R2 is 10 ohm plus R1, R3, it is 5 into 10. That's correct. Substitution of R3 is correct. It is 20 ohm. So correctly substituted. So 5 into 20 divided by 5 plus 20, which is equal to 14 ohm. Okay. So I have calculated the VTH and I have calculated the RTH. So two things are done. Now I will set up a Thevenin's equivalent network, which is equivalent to that complex network. Then I'll apply superposition theorem. So Thevenin's equivalent network will be like this. The voltage source, one voltage source, VTH is 4.8 volts. Only one resistance, it is 14 ohm, and load resistance will remain same. Now the load resistance, to consume a maximum power, I told you that load resistance has to be equal to the internal resistance for maximum power. That is what the maximum power transfer theorem says. The maximum power is delivered across the load resistance only when the load resistance is equal to internal resistance of the source delivering the power. So RL is equal to 14 ohm, then only the power delivered across the load is maximum. Now what is the value of load resistance? It has to be 14 ohm. The load resistance value has to be 14 ohm. By mistake I have written it as 14 volt. So make it 14 ohm. And one more thing is left. I need to calculate the power. So power is equal to I square RL. Substitute for I square. VTH by RTH plus RL whole square. And substitute all these things. Or you can say I have already derived an equation for maximum power along with the proof of the maximum power transfer theorem. You can directly take that equation, which is VTH divided by 4 RL. Okay. You can directly take that equation and substitute and calculate. Otherwise, you can do like this also. Okay, but this clearly you can understand the concept here by substituting like this. 4.8 divided by RTH is 14 and RL is also 14. Two are equal. Square into 14 volts. Alright, so if you calculate this, the maximum power comes out to be 3.60 watt. So I have calculated the value of load resistance to be connected to get the maximum power, which is 14 volts. And also I calculate what is exactly that power which is delivering, what is the maximum power, the value of the maximum power. I have calculated with the help of maximum power transfer theorem. Alright, two things are done. The problem, third problem is done. let us move on to the next problem, that is the fourth problem. So it looks to be a very simple one. Find the Norton's equivalent circuit for the network. Oh, you need to just convert this into a Norton's equivalent circuit. So it is given, the circuit is given, it's a 6 volts battery, 3 resistors, same in a complex manner, 2 ohm, 3 ohm, 6 ohm. Along with that, the load resistance is connected of 4 ohm. Alright, now we need to convert this complex network into a simple Norton's network, not the Thevenin's. It is clearly asked you to find the Norton's equivalent circuit. So it tells that this complex network is equivalent to a voltage source in parallel with the resistance. That voltage source being equal to short circuit voltage across the load terminal, and this resistance being equal to effective resistance across the short circuited terminal. So I need to calculate IN and RN. It is enough that if you calculate IN, Norton's current, and the Norton's resistance, that means you can able to build a Norton's equivalent network with a value of IN and RN. So you need to calculate IN and RN. Let's take the circuit and short circuit it across the load terminal and find the load current which is flowing through the short circuited terminal. I am calling it as IN. Alright, to calculate IN, to calculate the branch current IN, branch current, why I am calling it as a branch current? We have two branches here, one branch is R2, another branch is R3. Okay, so these are the two branches for the current. So I need to calculate the current which is flowing through R2 branch, which is what our Norton's current. Right, for the branch current you need to calculate the main current and the resistance. First let me find the resistance, effective resistance, not the Norton's resistance. This is the effective resistance which I am calculating to calculate the main current. Now how do you do the effective resistance? For the current, for the flow of current, first it go through R1. Again it divides at R2, R3. Achha. So for the current, R1 is in series, R2 and R3 are in parallel. So R1 is in series and R2, R3 are in parallel. Let us substitute it, R1 plus R2, R3 by R2 plus R3. So I am finding the effective resistance to find the total current. So it is 2 plus 6 into 3 divided by 6 plus 3. So effective resistance will be 4 ohm. Okay, I have find the effective resistance. Then the main current which is drawn from the battery is total voltage by total resistance. Total voltage is the battery voltage, which is 6 volts, by total resistance is 4 ohm. So 6 by 4, which is equal to 1.2 volts. So I have done the main current, I have calculated the main current. Now let me go for a branch current, the current which is flowing through R2 branch, which I am calling it as Norton's current. So it is a simple branch current formula, main current into resistance in another branch by sum of the two resistance. So main current is 1.2 into resistance in another branch. Look at the two branches. One is R2 and another is R3. It is 6. R3 is 6. Okay. 1.2 into 6 divided by 6 plus 3. So IN is equal to 0.8 amperes. I have done the Norton's current. I have calculated the Norton's current. Okay. Next is the Norton resistance. Okay, so we have a set of formula which is already established. The Norton's resistance formula is R2 plus R1 R3 by R1 plus R3. Students, you need to clearly define which is R1, which is R2 and which is R3. In the straight line, the first one is R1 and the next one is R2 and the middle one is R3. Okay, three resistors in a T shape. R1, R2 and the middle one is R3. Let us substitute it. 3 plus 6 into 2 divided by 6 plus 2, because R1 R3 are in parallel, now R2 is in series. This is the Norton's resistance which I am calculating. This is the resistance across the terminal, load terminal. This is the effective resistance across the load terminal. Don't get confused with this Rn and this R effective. R effective is the effective resistance for the flow of current. For the flow of current, this R1 looks series and R2, R3 looks parallel. But when you are calculating the effective resistance across load terminal, for this R1, R3 looks parallel and R2 looks series. So the point of the observation is what very important, and to judge which one is parallel and which one is series. If you are looking at the load terminal, R1, R3 looks parallel. If you look at the perspective of current, this for the current, this R1 looks series and R2, R3 looks parallel. Okay. So where you are observing, which point you are considering is what important here. Okay. So this will change. The parallel series combination will change as your point of observation changes. Okay. Alright, I have done this IN and RN. I have calculated the load Norton's current and Norton's resistance. I mean, with the help of this IN and RN, I can construct a Norton circuit. You need not write a Norton circuit. If it is enough that if you find IN and RN, it is understood that we can construct a Norton circuit with the help of IN and RN. Otherwise, if you want to complete it, you write another circuit with IN and in parallel with an RN. Along with that, we have a load resistor connected. Means a Norton's equivalent network to that complex network. You can write a Norton's equivalent network to that complex network as well. Okay. So these are some of the numericals. I covered almost all the theorems. I covered Thevenin's, Norton's superpositions and maximum power transfer theorem. These are the few simple examples which I have given. You get a lot of problems in the textbooks. You go through these, some of the textbooks, you will get number of problems. Work it out. Okay. So develop this problem solving skill, which will helpful for your exam. When you tackle an exam, any kind of problem you can tackle with this kind of problem solving skills, which you develop by solving more and more number of problems. Acha, thank you very much. This is the last video. I finally completed all the 60 videos for the second semester student. I hope you make this full use of these videos. You view this video, you can repeatedly view these videos at any point of time, at anywhere. Okay, you can sit anywhere and you can view the videos. Just make a notes of it. Complete PPT has been presented here. You can just make a notes of this. Write down the notes of all this. Okay, view the video any number of times. Clearly understand the concept. Okay, if you find any doubt, you can contact me anytime. Okay, so this second semester complete syllabus I have been done through this LMS. Okay, so make full use of this LMS. So I hope that this LMS will benefit all the students across the state. So you develop a knowledge, develop a deep thinking, and I hope these sessions, these videos may also be helpful for your examination. So thank you very much for viewing all these videos. Thank you.